everybody. My name is Al-Kaff, PhD student in Intelligent System Laboratory, and it's my pleasure to present you briefly my work, which is autonomous vision-based navigation system for unmanned aerial vehicles. Actually, I started this work in 3 months, and we implement something for the aerial vehicles. Starting with the aerial vehicles. Which type of vehicles we are using? We are using the quadcopter. And the question that everybody may always ask me this question: why quadcopter? Why you are using the quadcopter? Okay, we're using the quadcopter because it's accurately and efficiently perform the task. This task which is a mass risk for the humans. This is our first point. Second point, it has the ability of the vertical takeoff and landing, better than the other vehicles. More, it has the advantage of maneuverability due to its inherent dynamic nature. I mean, it can do the operations with more stability. Last one, comparing with its closed sister, the helicopter, it has a major advantage over the traditional helicopter is the fixed rotor population. It means we are working with the roll, pitch, and yaw with the 4 motors that gives us mass stability than the helicopter. That we are working with 2 motors. This is the reason what we're using the quadcopter. Okay. Now we have here some overview about the family of air vehicles with the aircraft. It has 2 types: lighter than air and heavier than air. The lighter than air, we have non-motorized, which is balloon, sim motor. Motorized is a plane, is the same like the balloon with a motor. We have also heavier than air. We have non-motor, is a glider. Motorized, we have plane, rotorcraft, we have helicopter, tricopter, hexacopter, and we have a vertical takeoff and landing, which is a quadcopter. Okay, this is the reason why we're working with quadcopter. Now, which quadcopter? In our case, we are working with the Parrot Argo. Parrot Argo, we have 2 versions. I will explain both. The first, we are working with the second version, Argo 2. It has the dimension of 451 by 451 millimeters. It's like square. It has the weight indoor hole with the protector. It has the weight of 420 grams. Without this protector, it has the weight is 380 grams. This is the older one, the Argo 1. It has some change. The weight is 360 or 400. The dimension is 525 by 550. Both of them, they have 4 brushed or brushless motors. The first version is brush motors. The second one is brushless motors. It has the battery of 11 volt milliampere. The second one 11 volt 100 milliampere. The charging of the battery is 90 minutes, and the time of operating depends between 12 and 16 minutes. The lower part consists of ultrasound sensors with 40 kilohertz and a vertical camera, which is a 64 diagonal lens wide CMOS sensor. It has a frequency of 60 frames per second, and the resolution is 320 by 240 pixels. Front camera. Front camera has 93 diagonal wide angle, 30 frames, and the resolution is 1280 by 720 pixels. In general, it has ARM processor. It has a DDR RAM 128 mega. Wi-Fi, the connection is Wi-Fi. It has USB connection for the video streaming. It has MEMS and 3-axis accelerometer, 3-axis gyroscope. This is the characteristics of the hardware. Now, the project. The idea of the project. The idea of the project is enable this low-cost quadcopter, which is attached with the sensors, onboard sensors and cameras, to do autonomous navigation in a GPS-denied environment, indoor or outdoor. The current work we are doing, it consists of developing a man-machine interface to control the quadcopter, consists developing approaches of detection and tracking the targets with two cameras, horizontal and vertical camera. Also development approaches of mapping and obstacle avoidance for navigation, developing a control system for autonomous navigation mode. In general, this is an imagine of in general we are working. We are working for the cameras, vertical and horizontal. The vertical cameras to detect the start end points, detect because of the fail of the ultrasound in some environments like grass, like carpet, it fails. For that, we are using the camera to detect for the landing and takeoff. Also using the horizontal camera to detect the obstacle, target, faces, depends to the task of the quadcopter. Now we will talk about the interface, MMB, the machine interface. We call it LC drone. This interface is a graphical interface, allow the user to control the quadcopter using the joystick and keyboard. We is getting the data from inertial measurement unit and the cameras from the quadcopter. Also, we are doing or we're applying some algorithm for detecting lines, faces, and objects. We can see here the interface in general. The interface, we have the camera. We are working now just with one camera, horizontal or vertical. In this part we have the color camera. This part we have the detection. Depends which type of detection we want. This is the reading. We have the battery level, some reading of the flying mode. We have some reading from the AMU, roll, pitch, the orientation. Here we have speeds. It's not working well, but at least we have some readings of the speeds. This is for the connection between the computer and quadcopter. Here we have some basic commands for the flying, like take off, landing, emergency button, sometimes not working. We have hovering mode. Here we have changing the cameras, etc. I will show you some videos we are doing for detecting some lines with different colors. We have this quadcopter and some lines. This is the controlling of the quadcopter using the joystick controller. The altitude here is 60 or 70 centimeters. Have some different kinds of lines, red and blue, green. Okay, this is what we have in the interface. This is the connection, start. So I select black color line. We have here the center of mass of the line. We have here the readings of the roll, pitch, orientation of the hardware, speeds, but speeds sometimes not work. It's not working well. The red color is not related. Okay, this is in general what we are working with this with the interface and the quadcopter. We are working now for line detection. We want to develop the control system for complete this part, and we will work for the vertical and for the with the horizontal camera for detecting the obstacles and everything. This is briefly what we are doing.
Questions?
Questions? English or Spanish?
I have a question. Just out of curiosity, what do you think about the IMU, the sensors of the angles? Are they giving the data fast enough, or do you think they're a good sensor?
Yeah.
Because it would be very interesting, since it only has one camera, based on that information of the IMU, to extract 3D information from just a molecular camera to obstacle avoidance and that kind of thing. Do you think it would be enough with the hardware of the air drone, or maybe buy some new sensor and put it in?
Yeah, but the idea is low cost. So
Yeah.
yeah, I mean, if there's some good sensors we can use, but with the price, I don't know. But if the price is low, okay, because the idea is low cost, we can substitute some sensors or some cameras. Because, for example, we have the vertical camera, a low resolution. We have some difficulties with that. But we can change some sensor. There's no problem.
So maybe with the sensor that you already have, it would be enough.
Yeah. Till now, it's enough. But in the future, if we need some, we can.
But with the camera, I noticed that you can detect pretty well the straight line, and was detecting color and the center of mass, and it just looks fantastic. I mean, my opinion that the infrared is great. But I was thinking, on the other hand, can you detect some other patterns besides the straight line?
Like what?
For example, I was just thinking, if I want to make it like autonomous flying, and I want to make the aircraft stop at a certain position, or even to pull back, or just flip flop, or explode, whatever. But let's call it.
I understand.
For example, if I put 3 dots to make it stop, can I?
Or stop sign or something. Yeah.
That will pass.
Yeah.
Ah, okay.
Quería preguntar por el retraso entre las imágenes que estamos procesando y el momento en el que se han tomado. ¿Cuál es el frame rate que hay en este momento? ¿Cuántas imágenes por segundo se están procesando? 4 imágenes por segundo.
The problem is the connection of the Wi-Fi. Because when it's very far, we have some problems with the camera, with the photo, with the image. Yeah.
¿Hasta dónde se quiere llegar con el proyecto? ¿Cuál es el alcance del proyecto? ¿Cuál es el objetivo último hasta el cual quieres llegar?
Usamos las 2 cámaras, una para detectar los obstáculos y la otra para detectar la tierra.
Vale. Ese es el objetivo final. ¿Sí? Y controlar las trayectorias.
¿Estás pensando en utilizarlo en entornos externos o solo para dentro del edificio?
No, externos o internos, los dos.
Y cuando sean en externos, la altura a la que se va a utilizar es la misma que, o sea, un par de, como se ha visto en el vídeo. Un metro, 2 metros.
No, in video, because we have the different lines. At the quadcopter, we can reach 300 meters, depending to the connection. Yeah. For that, in this altitude, we have fail of the sensor, ultrasound sensor. So that we are trying to use the camera, the vertical camera.
¿Más? Pues nada.